The next problem that we're going to work out states that Evan has taken Eva out to dinner to propose marriage and has hidden the engagement ring in her drink as a surprise. When Eva has finished her drink, she spots the ring beneath an ice cube. If Eva looks down into the glass at an angle of 61 degrees, but the ice cube refracts the ring at an angle of 42 degrees, what is the index of refraction of the ice? I'm going to start by by listing the information that's given to me, and I'm going to go ahead and label it as air, because we can assume that Eva is in the air, and then I'm going to label this side over here as ice. Now, we were given that Eva's looking at the glass at an angle of 61 degrees, so I'm going to go ahead and write in that theta in the air is 61 degrees, and that the angle in the ice cube is 42 degrees. It's asking for the index of refraction of the ice, so I'm going to go ahead and label it as Ni equals question mark. And over here, I'm going to go ahead and use my formula sheet for the constant. The index of refraction as air is 1.00. Now what I'm going to do is I'm going to write down Snell's law. Based on the information that I've been given and what I'm looking for, I'm going to go ahead and use the Snell's law equation. So Snell's law states that the index of refraction on the incident side multiplied by the sine of theta is going to equal to the index refraction on the refracted side multiplied by the sine of the refracted angle. It doesn't matter which one you put where, as long as you keep them on the side that they're supposed to. So I'm just going to make myself a note that I'm going to use this as the air side, and this is going to be the ice side. Now that we've made that distinction, let's go ahead and fill in our numbers with where they belong. So I've got, instead of the index of refraction, I'm going to actually put in the value multiplied by the sine of theta, and in this case my theta is 61 degrees, is equal to the index of refraction of the ice, which is unknown, multiplied by the sine of the angle, and in this side it's 42 degrees. I'm going to simplify this to make it easier to work with, and the first thing that I'm going to do is take my calculator and I'm going to press mode. By doing this, it gives me several options, and what I want to make sure is that degree is highlighted. If you have it in radians, you will get incorrect answers. So the first thing I'm going to do is I'm going to simplify this side right here. All I'm going to do is type it into the calculator just the way it appears on my calculations. So 1.00 times the sine of 61 degrees, close that parentheses, and I get 0.8746197071 equals NR times the sine of 42. I'm going to simplify this even further by finding out what this numerical value is, and I'm going to do that by simply typing into the calculator sine of 42, and I get this value. So when I write it in, it's going to look, the decimals are long, but it will be easier for me to manage the numbers. I have got 0.8746197071 is equal to 0.669130664 times this index of refraction, and that is our variable, that's our unknown. Because it's being multiplied here, I'm going to do the opposite, which is division, to cancel it out. And remember, whatever you do to one side of the equal sign, you must do to the other. So what I would do is I would take my previous answer, which is 0.87461977071, divided by the answer that the calculator has generated. And rather than typing it all in, I'm going to use my shortcut by pressing second, and then right here where the negative sign is, and it'll take the last answer it just generated. And so I get an index of refraction of about 1.3. And there are no units. The units would cancel out. And that's it.